So now I will take this little vial, this little glass vial with a lid. It's called a cuvette. Now normally in college you're going to see cuvettes and they're going to be like rectangular, not round, but we have colorimeters and this is the type they made for the equipment we have. And I'm going to fill a cuvette with each one of these solutions. And of course label it so that I know what is what. Okay, so I have put our 0.5 through 0.1 molar samples in these cuvettes and capped them. And then I've also prepared a blank. So this is just deionized water, and that's going to serve kind of as our calibration point. So here's our colorimeter, C-O-L-O-R, colorimeter. Here's where we're going to put our sample. Now this is just the blank, but we're going to put our sample in here and then close it up so that the only light is from inside the apparatus. We are going to, once we hook it up, we're going to push this one time when we have the blank in, and that'll calibrate it. Since we used distilled water for everything else and we have distilled water in the blank, that should work out. And then we will put our most concentrated sample in, and we will click start on the software that you'll see. It takes 2 seconds, and then we'll replace it with the next most concentrated sample, etc. Okay, I've hooked my colorimeter up, and then I have the SparkView program on my computer. So you can see I have a lot of options. I want to do the absorbance just so I don't have to do an extra calculation. Now you want to do, as we learned in class, the opposite color on the color wheel. So we really want the red absorbance, but I'm going to select red, green, blue, and orange just so that you can see that the red really does allow the highest absorbance of light, which is going to be beneficial for us to get the largest range of data. So I will unselect this first one. We don't want transmission. This is the one, transmittance. This is one we really want, but I'm just going to do all of these. Okay, so now we set this up. Now what we actually care about is this top left one. That's the one that's going to be a red absorbance. So our procedure every time is going to be to take our vial and use this lens wipe. It's called a Kim wipe. It's the brand name. And we just make sure that our fingerprints are all going to get off of that and any smudges. Okay, and then we're going to put this in our colorimeter, and this is our blank. So we're going to hit this button. There's a little green light. When it's done calibrating it, the green light will turn off. And then we should be good to go. We don't hit that button again. And that means that you can also use 0, 0 for your first data point. Okay, so then we're going to take our most concentrated solution and we're going to wipe, push it in here, and then we'll hit start. Okay, so it gets a little confusing because the colors are not aligned. You're looking at the purple value, okay? So that's the number that you're going to take down for your absorbance of the 0.5 molar solution. This is the 0.4 molar solution. So again, you're looking at the purple. That's the highest absorbance. That's the one we want because it's the red light. So write that value down. Next, we're going to put the 0.3 molar sample in. Okay, so write down the absorbance of red light, which is in the purple ink there. Okay, now we'll do 0.2. And finally, we'll do the 0.1. Okay, so now you should have enough data to complete your standard curve. So you're gonna have to graph that. Okay, so now we'll do our unknown. So that's our unknown concentration. So that one does not get plotted. And you can take your absorbance in the upper left there. So the other thing you can do is you can kind of look at your unknown on this scale and figure out where it would lie. Okay, it looks like it's definitely less concentrated than the 0.5. And if I put it next to the 0.1, looks like it's definitely more concentrated. You can just kind of like figure out where it might fit, but you know, it's harder to trust your eyes than the actual quantitative value of the absorbances, right?